Coming to you on a rare, I want to stress that, a rare weekend edition of Accelerated Geo. Again, this is not going to be a normal thing at all. It just where this was a mini day and where I thought maybe we should get online a little bit with some of the other geometry classes. I just wanted to give you guys a chance to work on this kind of at your own speed. Now, it says review, but the big thing today is going to be focusing on algebra. We're going to be bringing back things like systems of equations from Algebra 1, as well as substitution. Those are going to be kind of the two big ones today. Using the substitution method when we're working with systems of equations. Like, for example, a little throwback here, we got some algebra going on. We actually don't know what any of these three angle measures are exactly, but we do have representations for them. So they even tell us straight up, a system of equations may be needed to find the variables, and then, even more importantly, to then use what those variables equal to find the measure of each angle. So two things here. This is two things we need to find. We need to find out what x and y are, and then we need to find out what the angles are. So two things. First, we're going to need to find out what x and y are. Well, here's the good news. Look at what kind of angles we have here. Two lines, non-adjacent, 4y and x plus y plus 10. Those are non-adjacent across from each other. That means these are vertical angles. So we know that 4y is going to be equal to x plus y plus 10. So that's a great starting point. Now here's the thing. Which one do you want to solve for first? Because whatever we solve for, we're then going to have to plug into another equation to work it out. Well, look at what this other piece has. If we're going to find out what 2x is, then we're going to need to get x by itself in this equation, because x is the natural next stepping point here. So, as we're thinking about that, let's also notice that, wait, 4y plus 2x, guys, aren't these a linear pair? That's a straight line, isn't it? So this, that plus that, should equal 180 degrees. The problem is doing 4y plus 2x and setting it equal to 180. That's not going to help anything. But if we can maybe get x or y by itself, that might help. And I'm thinking x will be a good one to try and get by itself because x is already almost by itself. Check it out. It's just 1x. So why don't we subtract y over? And why don't we subtract 10 over? Kind of move both these away from x. And if you do that, bring it over here, you are left with, let me draw this arrow, you're left with x equals 3y. There's the bell. You can tell I'm doing this during school on Friday. X equals 3y minus 10. Now again, that's not actually what x is going to equal, but we can use this to substitute. Because if that's what x is, then we can do some replacing here. We can say, okay, normally we know that 2x plus 4y is going to equal the whole 180 degrees. So we've got that here. But because we know what x is, we can substitute in 3y minus 10, do a little substitution action, and we can plug in 2 times, in parentheses, 3y minus 10 plus 4y equals 180. And all of a sudden, you have an equation that only has one kind of variable in it. So I'm going to let you guys see if you can take some time and finish this for y. Finish for y here. Let's see what we end up getting. Okay, so when you work this out, 6y and 4y gives you 10y. add 20 over, you get 200, and then divide by 10, y equals 20. So we can use this information and say, okay, well, if y is 20, then I can plug that in for this angle over here. 4 times 20. This angle right here is really 80. And if that's the case, what do we know this angle over here has to be? Well, if this is 180, that's got to be 100 degrees. And think about it. If this is 80 degrees, and we know this is a vertical angle, these are congruent. So this also has to be at 80 degrees. Great, great job, guys. You can pause the video if you need a quick break. Good news is we got the toughest problem out of the way early. That's going to be our toughest problem of the day, in my opinion. A couple of these other problems are going to be similar, but I feel like they're going to be definitely a little bit shorter. Like, for example, we're going to, again, write an equation for each and solve for each angle. So read carefully here, guys. We got some good vocab. Angle A is going to be twice as large as its complement, B. When you see that word complement, we should be thinking complementary or 90 degrees. So angles that are complements of each other are angles that add up to be 90 degrees. So A and B, put them together, 90 degrees. So we already know angle A plus angle B is going to be 90 degrees. But something else we're told is A is twice as large as B. Okay. Angle A is twice as large as angle B. So how can you represent that? Well, you can do angle A is, think back to Algebra 1, we see that word is, we're talking equals, twice as large as B. How do you represent something being twice as large? You take B and you multiply it by 2. So 2 times, let me see if I can fit an angle in here. There we go. 2 times angle B would be what A is. And I don't know about you guys, but I'm thinking, wait a minute, if angle A is really just 2 times angle B, couldn't I substitute that into this top equation? Yes, we could. So really this top equation could be 2 times angle B plus angle B equals 90 degrees. So we can combine like terms. That gives us 3 angle B's. And when you divide, what do we find out? Well, angle B is 30 degrees. And here's where it gets easy, because you know if angle B is 30 degrees, you just plug that back in for trying to find angle A, and you just double it. So angle A is going to be double that, plus we know they're complementary, so they have to add up to 90. So angle A is going to be 60 degrees. So I'm going to let you guys try number 3, with the one hint being that A and B are supplements. So y'all already know we're talking 180 degrees. Also make sure you read carefully. A is going to be half as large as B. Half as large. So just keep that in mind. And I'm going to let you guys go ahead and try number 3. And if you're feeling really confident, you can try number 4. So go ahead. You guys feel pretty good on number 3. These add up to 180. A is half of B. So when we substitute in 1/2 of B, you add that with B to get 1.5. Divide by 1.5, you get B is 120. And since we know A is half as large, you could take that 120 and plug it in there and multiply it by 1/2. Angle A is really 60. Now, as far as the next hardest problem after number 1, it's probably going to be number 4. This is second place as far as difficulty goes. So let's really lock in here. Be very, very careful on this one. So the first step, pretty straightforward. E and C are supplementary. So we know angle A plus, not angle A, what am I doing? Angle E plus angle T equals 180. That part's very straightforward. Here's the tricky part, though. Angle E is, now here's where it gets kind of weird. Angle E is, so we know we've got an equal sign, 25 degrees more, so that'd be 25 plus, this is the part that freaks some people out, twice the complement of t. Twice the complement of t. What on earth does that mean? Well, twice we know means to multiply something by 2. So twice means 2 times something. Well, 2 times twice the complement of t, I'm sorry. We know complement means 90 degrees. And what would be the complement of t? Well, that would be the angle that if you added it with t would add up to be 90. So to find out what that angle is, you take 90 degrees and you subtract angle t. So to find out what the complement of t is, you take 90 and subtract t from it. That leaves you with the other angle. And so look at this mess. And I know a lot of you guys know what we need to do next. We need to substitute, right? We need to take this and substitute. The problem is, this is way too, you can substitute this in for E, but is there a way we could simplify this? Absolutely. Let's actually drop down here. If you wanted to substitute this, you could start by distributing. And so we would have, I'll switch to red, we would have angle E equals that 25 degrees plus 2 times 90 is 180, and 2 times negative angle t would be negative 2 angle t. We kind of treat the angle like a variable. I guess I could have mentioned that before, but if you notice, these angles are kind of like our variables. And so to really simplify, we could do one more thing, 25 degrees and 180 degrees. That means angle E is going to be, add those together, 205 degrees minus 2 angle t. And that is a heck of a lot nicer looking thing to plug in and substitute for E. So let me close that off and we'll bring our math over here. So we know we've really got, instead of angle E, we can replace that with 205 degrees minus 2 angle t plus angle t equals 180 degrees. And this is a good old-fashioned Algebra 1 equation. Let's just treat these angles like variables one more time. So negative 2 angle t plus 1 angle t. That's going to give us negative 2 plus 1 is negative 1. So we're just negative angle t. Same thing, negative 1 or just negative angle t. From there, we subtract 205 over. $180 minus 205 is negative 25, and then divide by negative 1. We get angle t is 25 degrees. And if we know angle t is 25 degrees, shouldn't angle E plus angle t add up to 180? So if angle t is 25, just subtract 25 from 180, and we find out that angle E is going to be 155 degrees. So, woo! That one was challenging as well. 1 and 4 are going to be by far the toughest problems on this very short day. So, let you guys kind of see our work there. I know it looks like a lot, but really it was just kind of some repetition. So pause, take a breath. We just got one last thing to look at. Last thing, last page, guys. These should look pretty familiar to you. And really, we're in luck. Algebra proofs are much easier in general than geometric proofs because really we're just dealing with algebraic steps like addition, subtraction, multiplication, and division. Sometimes distribution, substitution, things like that. But I want to point out that whatever comes after if is our hypothesis. This is always what we are given. And whatever comes after the then is always what we are trying to prove. So your first step on each of these three should always be to first write what we are given. So negative 1/2 x minus 1 equals 10. That is given. And by the end, we know that we should be having x equals negative 22. That's what we're trying to prove. You can go through here and do that for each of these. 1 and 4 you already know. And number 3 you already know what we should end up with here. So if you want, let's go ahead and we'll do one together, and then I'm going to let you guys take it home here. So on number 1, we've got our setup that's given. What can we do to solve and figure out that x is negative 22? How about, couldn't we add 1 over? Yes, we could. So through the addition property, we add 1, and that leaves us with negative 1/2 x equals, add 1 over, that is 11. And then to take care of that negative 1/2, we can divide by negative 1/2. And when you divide by half, it actually is like multiplying by 2. But since it's a negative, 11 divided by negative 1/2 is negative 22. And there you go. So I'm going to let you guys see if you can try numbers 2 and 3 for me. Give it your best shot here, guys. Oh, by the way, here's our givens and our endings. You can go ahead and plug those in, like I said, since we already know. Sorry, back to you. How'd we do, guys? Number 2, substitution, subtraction, and division. Number 3, addition, multiplication, and division. So you can pause the video if you need to look over those, but we've done it. Just want to remind you, we got a quiz on Monday. And you may just see something like this on there, guys. So make sure we study up, look back over our properties, and give it your best shot. And I'll be talking to you and hopefully seeing you soon. Take care.